All right, so hopefully you've given this one a try. Um, Now, before I get started, I want to talk about some of the strategies I use as I'm solving these systems of equations using Gauss-Jordan elimination. And one of those strategies is I tend to work one column at a time. I usually start with the column on the far left, and I try to get it in the form that looks like my goal, right? So I'm looking for, you probably saw when I did that here. I start by looking at this first column, and my strategy is to get a 1 here, and then use that to zero out the rows below it. And then I move to the next column, okay? And then I'm trying to get a 0 and then a 1. All right, so that's kind of my first strategy. Now, these are strategies. These are not hard and fast rules. These are not like this is the only way to do it. These are just strategies that that I feel like tend to make things go smoother. Okay, and so the other strategy that I use is to avoid fractions, and that's just my own personal preference because I know that as soon as I introduce fractions, and I'm having to add and subtract fractions with different denominators, and then I get all it's just very error prone as soon as I introduce fractions. So I try to avoid fractions if possible. So um, so let's take a look at this system of equations. Now I'm going to start by just writing the augmented matrix, right? 3, 2, -1, 4, 3, and 0. So an example, which I didn't really mention in that the last example, um, you might look at this, okay, I'm trying to get a 1 up in this upper left-hand corner. Now you might think, well, just divide by 3. That'll give me a 1. I can do that. I can multiply this first row by 1/3. That'll automatically give me a 1. But then I end up with 2/3 and -1/3, and then I don't want to deal with fractions. Okay, so that's why I always try to look for an alternative way to get a 1. And again, this is sort of like that other one. What I'm seeing is that it's not that easy to get a 1 here without fractions, but I can easily make this element in the matrix a 1 if I subtract row 1 from row 2. So I'm going to replace row 2 um, with row 2 minus row 1. Okay? And then you can see I can get a 1 down in this lower left-hand corner. So I'm not going to do anything to row 1. I'm just going to leave it, oh my gosh, leave it as it is. 3, 2, minus 1. And I'm going to subtract row 1 from row 2. So 4 minus 3 is, 4 minus 3 is 1. And 3 minus 2 is 1. And then 0 minus a minus 1 is 1. Okay? So watch your signs there because it's easy to get messed up. All right. So that's all I did. I subtracted row 1 from row 2. All right. So what's our next maneuver? Now, my next maneuver is to swap rows. That would be an easy way to get the 1 in the upper left-hand corner. So I'm going to interchange row 1 and row 2. Just swap them around. So row 2 becomes row 1, 1, 1, 1. Row 1 becomes row 2. So 3, 2, -1. Okay. Now I want to get a 0. I want a 0 right here. That's my next thought. Because I'm still working on row 1 and trying to get a 1 and then a 0 below it. So what I'm going to do is I'm going to make a little note to myself. If I take -3 times this whole row 1, right? This becomes -3, -3, -3. Okay? And then I just want to add that to row 2, and then I'll get a 0. So my row operation is that I'm taking row 2 and replacing it with row 2 minus 3 row 1. Okay? And I just made a little note of what -3 times row 1 looks like. I don't actually want to change row 1, because I kind of like that 1 there. I don't want to change that. So I'm just going to leave row 1 as it is. But I just made a note of what -3 times row 1 looks like. So now I'm going to add -3 plus 3 is 0. -3 plus 2 is -1. negative 3 plus negative 1 is a negative 4. Okay, so I get negative 4 here. All right. So I'm done. I'm done with row 1. I got the 1 and the 0. So I'm almost there. So I know what I want the second column to look like. I want the second column to be a 0 and then a positive 1. Now I could just multiply the second row by negative 1, but why don't I just use it as it is? And if I take row 1 and add row 2 to it as it is, then I'll get my 0 where I want it, and in this corner above the, in this one. This is the first row, second column, right? So when I do that, I'm just taking all of row 2 and adding it to row 1. So 0 plus 1 is just, that leaves it's 1. And then I add negative 1 to 1 and I get 0. And then I can add negative 4 to 1 and I get negative 3. And now I can actually do 2 row operations in one. Now that I've taken care of, adding, I've taken care of getting a 0 here, right? I'm looking for a 0 here. Now I can take the negative 1 times row 2. Okay, negative 1 times row 2 just becomes 0, 1, and then the negative 4 becomes a positive 4. And I'm done. I beat the system. I won the game. I've got my matrix in the form that I want it, so I can just read off the values. So this is equivalent to x plus 1x plus 0y equals negative 3, and 0x plus 1y is equal to 4, right? So that's telling me that x is negative 3 and y is 4. All right, now it's always worthwhile to check, because again, this process is a little error prone. It's better done by computers, I'll tell you that. So I'm just going to take the original set of equations and plug in this x and y value that I found, and it should satisfy both equations. So 3 times the x value, negative 3, plus 2 times y, which is 4, is that equal to negative 1? So I get negative 9 plus 8 is a negative 1. Checks out. All right, 4 times x, which is negative 3, plus 3 times y, which is 4, should be equal to 0. And you can see 4 times negative 3 is a negative 12, plus a positive 12 gives me 0. Boom, done. All right, we got the solution. All right. So, let's see. What do we got? Oh, that's it. Those are the 2 examples that we're gonna do today. And so the only thing left is discussion questions. So I'll meet you in class.